lists are one of those things that ends up being used all over the place in your code. And we've been using ArrayList for quite a while, and we've been getting by with 3 or 4 features of ArrayList, 3 or 4 different methods. And so I just wanted to recap some of the stuff we've done and also remind you of some other methods that are available that are fairly handy when you're working with lists. So here's a program with a bunch of students, and I did the usual make a list. And I keep reminding people that we do a lot of this sort of stuff where we just make the data. In fact, the making of the data and the adding of things to the list probably gets done in a GUI someplace. So it's the GUI that's giving you the data. And so, you know, everything that happens up to this point in time is just the idea that somehow in the program you managed to make 3 lists worth of student information, and now it's time to do something with them. Okay. So let's try doing a few things. How about making a copy of a list? How do you make a copy of all students? Okay, so we'll do something like this. Here's a copy, and the copy is make an array list and include all students in there. Okay, and that will use all students and make a copy. If I remove something from the copy, does it get removed from all students? No. Because they're different lists. So sort of that address book analogy works here. They're different address books. If I remove somebody's phone number from one, it's the same. What about if I change one of the students? If I change B student's name on all students, does it get changed on the copy? Votes for yes. Votes for no. So it does get changed because even though they're 2 independent lists, they both connect to the same people, just like phone numbers connect to the same people. And so if you talk to one and ask it to do something, then somebody else who calls and talks to it later on sees a different person. Things have changed about them, and that's just normal behavior. So that's normally the way we set things up. It is possible to make copies that are independent, but usually we don't, because this is the sort of behavior that we actually want. So if we change B student by changing their name, it will also change it if we go and look on the copy. Okay. Okay, so suppose I want to now see if those 2 lists are the same. The first question is, what does it mean to be the same? They've got the same, basically, students. What about order? This is where it gets tricky, right? If one list has ABC student and the other list has CBA student, are they the same list or not?
They contain the same students.
They contain the same students, but are they the same list? Okay. You have to make the decision. There's 2 ways of thinking about it. You can say, well, they have to be identical students in identical order, would be one way of saying they're the same. The other way of saying they're the same is to say, well, if they have the same students, regardless of the order, just as long as they have the same students. Okay? So it's more restrictive to say they're only the same if they have exactly the same things in the same order. Okay? So let's do that one first. So the question is, how do I check If I had to do this by hand, how would you check to see if they're the same students in the same order?
You want to print the list?
Don't want to print them, we want to do this in a program. So what makes them, if we say they have to be the same students in the same order, if you were doing it by hand, what would you have to do?
Compare.
Side by side.
You'd have to put the list side by side, and you'd have to say, is the first one here the same as the first one there? Is the second one the same as the second one? Is the third one the same as the third one? Okay? So we're going to have to go through each one of the lists in the same order and make sure they contain the same students. So it's a bit of work. Okay? So my initial reaction is always to write some sort of method and say, are the lists the same between all students and the copy? And just put that in an if statement. So if it's the same list, for at least our definition of same. Okay, so there's this idea. I don't know how to do it. It seems like it's a lot of work. So I'm just going to take a method. The method is going to return true or false to say whether or not they're the same. And we'll just give both of those lists over to the method to do the work. And then we'll come down below and write the method. And since I'm working in a main program, I'm going to have to say static. It returns a Boolean. And it takes a list of students that's really just list A, and a list of students that's really just B. And just to be clear, rather than having A and B, I tend to like to say they're just more than single variables. So I want to put some word on there that just sort of describes a little more idea of what they are when I see the variables. So there are a couple of different lists, and the technique here is to always come down to the bottom and say, well, we'll just say that they're always the same. And now we'll worry about what if they're different. Okay? So you're going to have to go through the lists and check to see. So go through all of the items on one list means some sort of loop. The thing we've said all along is to write a for each loop, right? So for student, a student in a list now what?
Well, you need to check the decision again.
You have to check to see whether or not a student is the same as the first student on the B list. So we need B student here someplace in order to do the check.
Would a while loop work better?
Question was, would a while loop work better? The answer is still probably no. You're going to both do the same thing. The problem that you're running into is that for each by definition only goes through one list of things, not two lists of things. And it's actually sort of difficult to make it go through two lists of things. You really can't do it unless you play some games. Okay? So do you want to do this one first, or do you want to do the easy one? We'll do both. Let's do the easy one. If this were a counted loop, what would you do in place here for a counted loop to go through all of the items? counted loops, always write int I equals 0. I is less than however many items are on the list. A list dot size I plus plus. So if we just went through all of the items, what would be the thing that you wanted from a list?
The position I in A list.
So that's the position I in a list is a list dot get the I position. The guy from B list would be B student, and he would be on the B list. And then what? We got each one of the students.
But we are, on the loop, we're going through the A list, but not to the B list.
No, we're actually not going through the A list at all on the loop. We're just going through A list size. So we're just counting the number of items. So that's got, it's just a count of things happen to have gotten from A list. But we don't actually retrieve the students till here, so we're getting both students from A list and B list. So how do you see whether or not they match? So you can use dot equals. If we wanted to make sure they were identical, so again, the most restrictive thing we can do is if we can say if A student double equals B student would be they're the same. And in this case, we're saying if they're not the same, then it's not, then they're not the same list. So we're just going down each position on the list and checking to see whether or not they're the same. And if we just do that for a start and run it, we get the correct answer as far as testing goes. What other things would you test? Well, I mean, not that the names are the same, but just, I mean, we've already got this test is identical, right? So we don't have to worry about testing names or anything. They have to have the same phone number, so they're pretty much guaranteed to be identical. Okay? What would you test for different kinds of lists? What would be the weird cases? What about the sizes? This thing assumes that they're both the same size. What if one list is shorter than the other? So we have to worry about that because we could get to this point, and if the first list was shorter than the second, we'd have a problem. So should we use A list size or B list size? If we use the smaller in that loop, then we won't see all of the ones on the longer list, and if we use the longer run, we'll run out of items when we get to that point on the smaller one.
But now, if B is a copy of A, do we add extra things to B?
You can't add, you can't change the list when you're checking it.
But no, I mean, like, why would it be longer B than A?
If somebody changes it afterwards.
So you can...
There's no reason you can, they're two different lists at this point in the code, so there's nothing to stop you from changing the copy and adding, removing things later.
So that's my question.
So at some point here, they could be different. Again, remember, this thing refers to a whole bunch of different instances in time.
Before you go through that for loop, can you just compare the size of A and B list and project if they're different sizes?
Right, his comment was, well, we should check beforehand. By the way, it's a bad idea to try to check inside the loop, because that's just very complicated. You might as well check before the loop even bothers to start, because if their sizes are different, they can't possibly be the same list, period. You don't even have to check the items. So if a list dot size is not equal to b list dot size, then they're not the same. Okay? Notice that we still wrote this in that rejection style. We said, let's do the easy case first. Let's see if they're the same, right? So we really wrote the, oh, they're just the same, always true. Then we started with rejections, so that's really a rejection. Oh, here's a reason why they wouldn't be the same if they didn't match up someplace along the line. And then there's another simpler rejection. Oh, if their sizes aren't the same, then we know they're not the same. And if you write it that way with the rejections, you're going to end up with much easier code than if you try to figure out inside of the loop whether or not they're suddenly not the same for some reason. Okay, so you do the work up front, and that's a lot easier. Okay, so this is actually same list with, we'll call it the counted version. So one of the things that we've discovered is that for each is nice because the syntax is easy, but it doesn't work well when you're comparing two different lists, because for each is designed to really only go through one list at a time. But just for fun, let's do the for each version also. So we'll write a different version here. I'm just going to name them differently so we can keep track of them. So suppose we wanted to do the same thing with a for each. We said we'd start out and we'd write a for each to go through one of the lists. So that was grabbing a student out of the list. So inside here, a student is going to change. How do you get b student? You don't want to do another loop in here, because another loop implies you're going through all of them and you only want just one of them at this point. So what are your two choices for grabbing a student off of B list? There's only two ways you can go about getting a single student. We could get them by the position, so we could also put a counting variable up here. So we could say in B position starts at 0, and then we could go get the B position, and then remember to increment B position for the next time around, and then do our comparison, just like we did before. So it's basically, now that we've got the two students, we can see whether A student and B student are the same, and we'd end up with something more or less like that. What am I missing there? I guess I'm missing a brace up here, probably. Oh, I didn't change this one to for each. Okay, So there's that idea that the for each only goes through one of the lists, and you still end up having to have a counter value for the other loop. So this is a case where that one's just the better deal because it's more obvious what's going on. It's one for one. And it's actually more obvious if you, believe it or not, write it like this. So we'll get rid of that and just put that in there. And that in there, and get rid of those variables and write it like that. Okay, so this is a case where I find that removing the intermediate variables actually makes it more obvious because you get the two things each on the same line, and you get the sense of we're comparing one for one with exactly the same positions as you go down. So it's quite often you'll see it written this way because it just looks nicer. It gives more of the sense of what you want. Okay, let's go back to this one. We know that usually with for eaches, we see iterators involved. So our other choice, rather than using a counted variable for this, is to use an iterator for the list instead and make iterators and for eaches work for both examples. Okay, so in this case what you would do is you would say iterator that's going to give back students talk to blist and get an iterator out of it. So now I've got my starting iterator. And here when you go to retrieve it, you no longer talk to the list, but you talk to the iterator instead. So this is iter dot next. And notice that one of the joys of iterators is that it does the incrementing for you, the advancing for you, so no need to advance. Okay, so one of the primary reasons for using iterators is that they'll just keep advancing and get to the end, and you don't have to worry about that. Okay, but still basically the same idea, as long as you remember to talk to the list to get the iterator, and then just go through them one at a time. Except this is the good case. Any issues with that case? The length of the list is a problem because if this list, the first list, is longer, then we're going to run out of elements by the time we get to there. And remember, this program will die if you get to here and there aren't any next items. So what do we need to do? We need to worry in here that this is going to be a problem, which means here we need an if statement to say if iter dot has next is false, meaning there's not another one, then we would return false. And that takes care of the case where this list, the A list, is longer than the B list. What if the B list is longer than the A list? How would you know?
have to compare the two lengths at the beginning and know what
The question is, can you compare the lengths? The problem is that iterator doesn't really give you a length,
but before that.
so we could do it before and make sure if the lists aren't the same, or just to dig ourselves into a little deeper hole here first. What would you do to know that B-list was longer? How would you know? If you get all the way to the end of the loop, that means you've exhausted A list. How would you know that B list still has things on it? Has next will still be saying true. So if you get all the way to the end after you've done the loop and you discover that has next is true, meaning there's still items left on B's list, then you know that you've still got items left. And notice how this word, if I change this to, just to remind myself, I'm going to call it, instead of iterator, I'm going to call it B's just to give the exact sense of what it is, that it's B's iterator. Okay, so notice what happens that if you make that mistake of saying, I'm going to worry about the lengths of the lists inside, or as I'm going through them, that your life all of a sudden starts to get difficult because you now have to worry about what if one is shorter than the other here versus what if it's longer than the other there, or vice versa, whatever it happens to be. Well, the simpler solution is, like we said, before you even get to the iterators, if you just go down and use the size, because if we have the lists, we can use the size. Then we could just return false and not do that. Okay. Let me just make this one a little more complicated by saying, suppose that we don't get lists here. But what we get is an iterator instead. I'll have to rename these in a moment. So that in here, suppose that the only thing we had was all students.iterator and copy dot. We didn't want to give them the actual list, we just gave them the iterators. I can't do size because iterator doesn't have a size method. I've already got the iterator. Oops. And I can't do a for each here. So this becomes while a list dot has next. And this is now, I'm going to have to fix this up, so I might as well get the iterators in here. Just going to do the iterator version. This is now a iterator and b iterator. And a student is the guy from here. right? There's the iterator version, almost. That's pretty close. Okay, so the nice thing before, when somebody gave us lists of things, is that if you have lists, you can check to see whether or not the sizes match, right? So there's an easy check, and it makes things really, really easy. But if somebody gives us iterators instead of lists and says you can't check the sizes, your only choice is to use the iterators to wander through all of the items one at a time to make sure that they're the same. Okay, so there's several combinations here. There's lists versus lists, there's iterators versus iterators, and there's lists versus iterators as things that people could give you in order to say, well, do these two things have the same stuff on them? And the easiest cases, the absolute easiest cases of the works is to just, if you've got two lists of things, if you get any lower than lists down to iterators, you're sort of lacking in information and you have to do it a little bit more the hard way. Okay? But either of those two will sort of work for doing comparisons. This one's already a little fishy in the sense that you can see that we're checking for conditions of are the lists the same length. So this is a good idea of, if we're planning on doing it more than one way, to make some unit tests and have the unit tests say, well, here's two lists of equal lengths that are the same, here's two lists of different lengths that are the same up until they stop. You know, A is shorter than B versus B is shorter than A. And if we do all of the combinations in unit tests, we'll have a lot more assurance as to whether or not the code is right than just sort of looking at it and going, oh, I think I've sort of covered the cases there. Okay? So I'm not exactly sure that this is 100% correct, but unit tests would tell us for the differing lengths of lists. But the point is that when you've just got iterators, you're going to have to go through a lot more trouble to worry about whether or not you're running off the end of the lists, because the thing will die if you don't. Okay, so now the question is there an easier way than doing all of this work ourselves? And just out of interest's sake, let's try this one. If copy dot, oh look, list has an equals method. And you can't quite see all of the words for it there. But it says both lists have the same side, corresponding pairs of elements are equal, and from the looks of things, that means it can either be by, it's done by the equals method for the two items. So it looks like it will say at least whether or not they're sort of the same. So we can use dot equals here. And this would be either the same with equals, with lists equals, and this would be the same with iterator version. Hopefully my iterator version isn't too messed up, but we'll find out. And I guess my iterator version is somehow not quite right because it didn't print anything, just the counted one did. That one didn't think that they were the same. Let's just go down to this point because I always get a little paranoid, and let's use the debugger, and let's just didn't even get to there. That's a little weird. Oh, yeah. Why isn't it getting to this point? There's nothing in the way. I hear my fan running. I'm stuck in an infinite loop. Why would I be in an infinite loop? If it printed out this, and it didn't ever print out that, or it didn't ever stop there with the debugger, the thing that's in the infinite loop is someplace in there. And so there's a bug in my list the same with the for each. So where is that, what makes that loop an infinite loop?
Something wrong with the while there, doesn't open up this.
So that belongs there. And that belongs maybe someplace there. I guess it's almost right. No, I'm missing a brace. Let's run source format here for a second and just see if it straightens out the loops for us. My return says my return statement is in the wrong place, so this thing needs to be down there. Oop, I should kill that one off. Okay. So there was that common problem with the braces of if you don't put a brace in or you get it in the wrong place, it only associates with the next line, which is what that was doing. So it was being an infinite loop because there were just two calls to has next without there being a next to actually stop the loop. So the only way that this has next is going to stop is if someplace in the code there's something that does a next, because that's the thing that's making it advance. Okay, and so that misplaced brace led to an infinite loop because it just associated the while loop with the if, and we never ever got to doing the next. Okay, well, hopefully that made my code a little better. I guess we've still got a bug in it, though. But at least we got the same with equals. We'll have to go hunt down my bug in this one a little bit later. Not so concerned about it. Okay. So now you've got your choice. You can write the things the easy way with a counted loop. You can write the things the nasty, difficult way with iterators and has next and for each, or you can just do the really simple thing and do equals method here from the list, and equals method in the list is already built to do the right things and worry about lists that are shorter or longer and all of that sort of stuff. Okay? When the equals method for the list decides to check to see if students are the same, how's it checking to see if they are the same? Double equals or dot equals? Are they checking, is it checking identical or looks similar to? Answer to the question lies probably where? In the student class.
Yeah, I can go ahead and
Okay, and my student class happens to have an equals. If you want to see whether or not it's being called, what we'll do is we'll just do this. We'll comment out these guys just temporarily, just so that we get, oops, not quite in the right place. Oh yeah, that's close enough. Okay, so I've just got list's version of equals, and I've got, I'm going to take out that breakpoint, and I'm going to go put a breakpoint inside the equals method for student, and we'll just see whether or not it's being called. And it's being called. Okay, so the takeaway from that is that the equals for list just calls the equals for students with first student against second student in order to see whether or not they're a match, which means you actually have control over, are the students on the list identical or are they similar to? Because if you have an equals in student, you get their similar students on each of the lists in the same order. But if you leave out the equals and don't write one for student, then you get their identical. Okay, because you're not overriding the equals. Okay, so if you don't write the equals, you get identical. If you write the equals for student, then you get the two lists are the same because they have similar students in exactly the same order. Okay, so there's the start of our playing with lists. That's a good place to stop. So the bottom line of all of that was we had a little fun with for eaches versus counted loops, and then at the end we discovered, well, it really doesn't matter because there's one that already does the work for you, because that's a really common operation. And with that, we're out of here.